Have you ever really thought about your very first breath? What did it take to get there? Well, today, we're going to dive into one of the most amazing construction projects in all of biology, the 9-month journey of our lungs, from just a tiny fold in an embryo to the powerful engine that keeps us going for a lifetime.
And right away, this brings up a really fascinating biological puzzle. How on earth does a developing embryo build this incredibly complex machine that it won't even need for almost a year? An organ that has to work perfectly, literally from the first second of life. So let's unpack this incredible story, right from the very beginning.
Our story kicks off super early, around the 4th week of development. This is when the very first hint of a respiratory system shows up. And it doesn't start as a lung, not even close. It starts as something way, way simpler.
And get this, our entire airway, I'm talking the trachea, the bronchi, all the way down to the lungs, it all starts right here, as a tiny little groove in what will eventually become the throat. You can think of it like the first chalk outline at a construction site, a simple mark that shows where this incredible structure is going to rise.
Now, right off the bat, the embryo has to solve a critical problem. You've got to separate the windpipe from the food pipe. It does this by basically building a wall. As that initial groove gets deeper and becomes a tube, these little folds start growing inwards from the sides. They reach for each other, meet in the middle, and fuse. And just like that, you have a partition, the Tracheo-oesophageal septum. It's a brilliant piece of biological engineering that makes sure air and food go down their separate highways.
Okay, so we've got a tube, but a single tube is not a lung. The next phase is where things get really intricate as this one simple structure begins to branch out, creating this amazing internal tree.
Just as week 4 is wrapping up, the bottom of that tube does something huge. It splits in two. These two new growths are called the primary lung buds, and this one single event is the foundation for everything that comes next. It's the moment that establishes the future right and left lungs.
And here's a really cool detail. Our bodies are not perfectly symmetrical. To make space for the heart, which sits slightly to the left lung only develops 2 lobes. The right lung, on the other hand, gets 3. And this isn't just some fun trivia fact, it has real-world consequences. The right bronchus ends up being wider and more vertical, which makes it the most likely place for any accidentally inhaled objects to end up. It's a direct result of this early design plan.
From this point on, the growth is just explosive. I mean, look at this timeline. By week 5, you've got lobes forming. By week 7, you've got distinct segments. And by week 24, get this, an incredible 17 generations of branches are already in place. And the construction isn't even done at birth. Another 7 layers of branching will develop as a child grows. It's just amazing.
So, building this tree of airways is one thing, but making it actually work is a whole other story. Now we shift from just pure architecture to getting the lungs ready for their ultimate job, breathing air.
The lung's maturation happens in 4 key stages. First, you have the pseudoglandular stage. Think of this as just building the plumbing, laying down all the airways. Then, in the canalicular period, blood vessels start to wrap themselves all around these new airways. And this is where it gets really important. During the terminal sac period, primitive little air sacs form, and those blood vessels get super close, setting the stage for gas exchange. Finally, the alveolar period, which actually goes on for years after birth, is all about perfecting that connection for a lifetime of efficient breathing.
And all of that brings us to this one absolutely critical number, week 24. This is the moment the terminal sac period begins. It's the point where enough of those primitive alveoli and their partner capillaries have developed that, in theory, gas exchange is now possible. This is what marks the threshold of viability for a premature baby.
But wait, there's one more piece to the puzzle. One single biochemical key that has to be in place for these brand new lungs to actually work in the outside world. This is the real game changer.
That key is a substance called surfactant. It's made by these specialized cells in the alveoli, and the easiest way to think about it is like a microscopic, non-stick coating for the inside of your lungs. Its whole job is to fight the incredible surface tension that exists where air meets the moist tissue of those tiny air sacs.
And the difference it makes is just night and day. Without surfactant, that immense surface tension would cause the tiny air sacs to collapse and stick shut with every single exhale. It's a condition called atelectasis. To put it simply, surfactant is what makes breathing possible. It props the alveoli open, making sure they're always ready for that next breath of air. And would you look at the timing?
Surfactant production starts kicking in right around that week 24 viability milestone we just talked about. By weeks 25 to 28, there's usually enough of it to stop the alveoli from collapsing, which gives a premature baby a real fighting chance to breathe on their own. The biology just lines up perfectly.
Okay, so let's bring this all home. Let's see why understanding this whole 9-month journey is so incredibly important in the real world for real people.
This quote from our source material really gets right to the heart of it. When this beautifully choreographed process goes wrong, specifically with making enough surfactant, the consequences are really, really severe. Hyaline membrane disease is the main driver of what we know as Respiratory Distress Syndrome, or RDS, in newborns. Without enough of that nonstick surfactant, the alveoli collapse, the lungs fill with fluid, and it becomes incredibly difficult or even impossible to breathe. This is exactly why the development of artificial surfactants has been such a massive, revolutionary breakthrough in neonatal care.
And so there we have it, the biography of a lung. Its incredible 9-month journey from a simple groove to a branching tree with hundreds of millions of air sacs, all coated with a life-saving molecule, timed perfectly and ready for a lifetime of breaths.
It's a powerful reminder of just how complex development really is. And the lungs? They're just one chapter in this amazing story. It really makes you wonder what other biological clocks have to tick in perfect harmony for a newborn to make that huge transition from the womb to the world. It's truly an incredible symphony of biology. Thanks for joining us.